So after having learned some of the basics of the Git version control system, next we're going to learn about an accompanying tool, a web app really, called Github. Now these two entities are separate and they have different people working on them for different reasons. So Git is an open source project. GitHub is a company whose primary purpose is to make money. GitHub provides Git hosting services to organizations with a much more modern, clean, web-based user interface. In addition, it offers other project management and collaboration tools that software teams make use of, like issue trackers and code review tools and project documentation tools. So GitHub offers free repositories as long as the code is open source. Okay, and what this means is that the repositories are available to anyone who visits the GitHub site. Visitors can read the code, they can copy the code onto their own machines. There's nothing private about the code. Okay, they charge people and organizations that are working on proprietary software that don't want the general public to be able to see their code or their repositories. This is how GitHub makes money. Before we begin to look at the GitHub website, I wanted to point out that GitHub has made a graphical Git client so that we don't have to work from the command line. The tool allows us to interact with Git and GitHub from a desktop GUI app. Now this is not the only graphical Git client out there. There are several others that I know of. But GitHub's desktop tool integrates seamlessly with the GitHub web app. Now these days, some modern text editors have Git functionality built in. Visual Studio Code, for example, is one of my favorite editors, has many of the features for working with a Git repo built right into it. So it may not even really be necessary to use a tool like GitHub Desktop, but I'm going to spend a few minutes showing you how to use it. So this is the download page for GitHub Desktop. Okay, here's the URL. You can download and install this on either Windows or Mac. And then once you do download and install, when you open GitHub Desktop, it looks like this. Okay, and what I'm going to do is I'm going to create a new repository. And I'm going to do all of this work on my machine. We're not talking about the GitHub web app yet. So everything I'm going to do is basically what I did in the previous video, but I'm going to use this GitHub desktop user interface. So the first thing I'm going to do is create a new repository. So I'm going to go up to the File menu, say I want a new repository, and it's going to ask me for a repository name. Call this branch project, and I'll put it in my home directory. Okay, this is equivalent to performing a git init from the command line. And you can see in the File Explorer that there actually is a Git folder. So here's the branch project, and here's the .git folder. The tool adds this other file, this Git attributes, that holds some Git specific data. Okay, if we go back here, we zoom in up here, and we'll see that we're currently on the master branch. Okay, this is where we are able to switch branches. This is equivalent to the git checkout command. Okay, so let me open this repository in my editor. Here's that one file that was added by GitHub Desktop. And again, it has to do with some properties of the text editor. Okay, what I'm going to do is create a new file called names.txt. Okay, I'm going to add my name and save. Then I'm going to go back to GitHub Desktop. And if you look up here, there's a tab called Changes. And it's actually identifying a change that it found from our current repository. Okay, on the Changes tab, you can see the changes to the files in the repo. This is equivalent to a git diff. Okay, any differences between the working directory and the code in the repo will be shown. So additions and deletions are highlighted. And what we're going to find is this is a much more pleasant view of the diffs than the output we get with the command line tool. So you can stage and commit your changes by supplying a commit message and hitting the commit to master button down here. Okay, so there's my commit message. I'm going to just hit the commit button. Okay, let me add a few more commits. Okay, first of all, notice now there's a diff here. Notice the addition of this line. Again, the desktop tool noticed the change and automatically put a diff up on the screen for us. I'll go and commit this. Okay, so after we do a commit, there are no more changes from the working directory compared to the repository. So the Changes tab is always empty after a commit. If we go to the History tab, which is right next to it, we can now see all of the commits that have happened. Okay, and if we actually start clicking on these commits, we can see the state of the files at each commit point. Okay, this is equivalent to git log. Okay, and you can notice up here, for each one of these commits, there's information about the author. That's the hash ID. It tells you about when the commit happened. So all the information you would normally get in the log, you can see in the tool. Now, just to prove to you that this is really just a plain old Git repo, I'm going to cd into this folder that I created, branch project. I'm going to list the contents. And then I'm going to use git bash to look at the log. Okay. So this is just a normal Git repo. The only difference is that we're using a GUI tool instead of the command line. And if you want, you can go back and forth between the command line and the GitHub desktop. Okay, next we're going to create a branch to add the professional title like we did in the last example. So I'm going to go up to the branch menu and say I want to create a new branch. I'm going to give it a name, and it's going to create that branch. Okay, if we go up to the branch tab here, we'll see this is how we can see what branches there are in the repository and allows us to check out different branches. Okay, so we can see we're in the professional title branch. So I'm going to go to my editor and add the professional title with the mistake, of course. I'll save that, go back here, look at my Changes tab. Yep, there's a change there. And I will commit this. If I look at the log, we'll see, yep, there's the diff. Let me go and fix that typo. Save, go back to GitHub desktop, look at the changes, and we'll see, yep, there's a change there. Okay, if you switch branches, the editor is going to be changed to reflect the contents of the current branch. So notice here we're currently in the professional title branch. If I go here and select master, this is equivalent to checking out the master branch, and I go back to the editor, we'll see we don't have that title anymore. That's because the editor, the working directory, always reflects the current state of the branch that's checked out. In this case, it's master. So if I go back to desktop and I check out professional title and go back to the editor, we'll see now we have the contents of that branch with the PhD in it. Okay, next I'm going to add a middle names branch. So I'm going to go up here, say I want a new branch, call this middle names, And of course we want to build this off the master branch. So GitHub Desktop is making sure I'm working off the master. So now we're in the middle names branch, and I can start to add the middle names in the editor. Okay, I'll save that. Look at my changes. See, yep, we need to commit these changes. Okay, I'm going to go back and change my mind and use just initials. Save that. Commit those changes. Okay, so now I have these two branches. One branch with the professional title, one branch with the middle names. Now what I want to do is I want to merge the professional title into the master branch. So the first thing I'll do is check out the master branch, because whenever you do a merge, you always want to check out the branch that you're going to merge into. And then I'm going to go to the branch menu up here and choose to merge into the current branch. And then it's going to ask me which one do we want to merge in. I'm going to start with the professional title, so I'll just select that and then click the button to merge into master. And now notice we are definitely here in the master branch, but if you look at the commits, okay, we have all the changes from the professional title branch are now merged into the master. Okay, next I'm going to merge in the middle names branch. Okay, so again, we're currently in the master branch. I'm going to choose this merge. I'm going to select middle names, hit the merge into master, and we get this error message that says there were some conflicts found. That's expected. Remember, there's that one line where there are changes from both branches. And it's going to change what's in my editor. So I have to go to the editor now and clean it up. Save that. And commit these changes. Okay, notice we're still on the master branch. If I look at the history, in the latest and greatest here we have both the middle initials and the professional title. Okay, so to me this GUI app has a lot of appeal compared to working from the command line. One can get an intuitive sense about how to do things with a GUI-based tool. And once you know where the common buttons and menus are, this tool seems a lot easier to use and shows a lot more information on the screen. Now there are a lot of people who prefer to use the command line tools instead of graphical ones. And I understand that command line tools really can be combined together with these things called pipes to make them very powerful. So for power users who really know what they're doing, that's a compelling reason to use the command line. But for your average computer users, the command line seems rather cryptic to me. So a friendly GUI app like this one groups the most used commands together and provides a nice interface to use them. Plus, there's typically much more data available on the screen when you have a GUI app. Now with the GUI app, there's no need to memorize command names. One can focus their energy entirely on writing code and solving problems, rather than some tool. I often wonder if command line proponents want others to perceive them as being more sophisticated than they actually are. So memorizing esoteric commands doesn't really say anything about your problem-solving abilities. It may make your mother think that you're smarter than you actually are, but I'm generally not impressed. And I'm pretty passionate about this because I think command line tools have the potential to scare newcomers out of computer science. You know, they just look so foreign and difficult to use compared to how we use our iPhones and our iPads that I can imagine people being turned off from programming simply because of the command line interfaces. Alright, so that's the end of my rant. If I've offended anyone, feel free to write me a strongly worded letter, written in VI or Emacs, of course. You might have noticed that the GitHub client pretty much hides the staging index since we don't have to explicitly add things, but it does still exist. In fact, you can deselect files and even deselect lines that you don't want in a commit, and then they'll stay and they could be committed later. A remote repository is one where the repo is on another machine. So Git allows you to communicate and coordinate with other remote repositories. Now this might be a colleague's machine, or it might be a web app like GitHub. Now of course, in order to do this, you need a network connection. All the things we've been doing so far have not required one. So we can send and receive changes from other remote repositories. It then becomes somewhat easy to set up a coherent plan for sharing people's work. You designate one machine the central server that will hold all the latest and greatest, and then the team works with that as a starting point for any new work, and the final destination once the work is complete. A fetch is an operation that allows you to retrieve changes in a remote repository that are not in yours. So if Bob and Alice are working from the same repository, and Alice gives Bob access to her repository, then Bob can fetch her changes and bring them into his. Now the changes are exactly the same on both machines. They're the same change sets, the same hash IDs, the same commit messages. So the changes are not automatically integrated into Bob's, they're kept separate. All of the branches that Alice has in her repository are now accessible in Bob's repository. Bob can check out Alice's branches to see her work, or he can merge his code with any one of her branches. And that's how they communicate and share their work. A pull is the combination of the fetch command followed by the merge command that we looked at a few times now. So if you know for sure that you do want to incorporate someone else's code in your repository, you can issue just a single pull command and save yourself from having to type git fetch followed by git merge. So that's all a pull is really, it's grabbing the changes and attempting to merge them into your repository. If there are conflicts, you will have to resolve them and make a new commit, of course. So a push is how we take changes from our machine and send them to another. It's very much like a pull, except we're sending changes to another's machine instead of receiving changes from another. So push sends changes to another machine, fetch retrieves new changes and adds them to your local repository, and pull fetches and merges in one step. So there's a typical workflow when coordinating with others on a repository. So there's usually one machine that's set up to act as the main repository. It holds the latest and greatest version of everyone's code, and usually it's on the master branch of that repository. Okay, then what developers will do is they'll make a copy of the main repository on their local machine. We call this a clone. Okay, then they make changes to their copy of the repository, they commit their changes, and they repeat this over and over as long as necessary. When they're ready to add their changes back to the main repository, they first fetch the latest changes from it, okay, if there are any. Now intuitively, you might think that the next thing they should do is push their changes to the main repository, not do a fetch, but we want to hold off on that, because others may have committed changes to the main repository since you copied it, and we don't want to have any conflicts in the main repository. So before you push your changes, you should always retrieve the latest and greatest and then merge it with the changes on your machine. Then, when you know for sure your code works with the latest and greatest, well, then you can push. And you may have to coordinate with others if there are conflicts from the master branch. So you may have to get on the phone and talk to people about how you can have your two change sets work together. So after you fetch the latest changes, you merge them into your repository on your working branch. Then your repository will now have your latest changes and the latest and greatest version of the code from the rest of the team. Finally, then you can push your merged changes into the main repository. So here's a little picture of what might happen. Both Bob and Alice, they make copies of the master branch on the central server. Bob and Alice do their work concurrently. Let's say Alice finishes her work first. So what she's going to do is she's going to attempt to fetch any new changes from the master repository. But since there aren't any, nobody has committed yet, she actually doesn't have to merge anything. There is nothing to merge in. So she will just push her changes to the central repository. Now if Bob comes next, and now he's done with his work and he wants to incorporate his changes to the master repository, he is going to fetch from the main repository, and there are changes now. Alice's changes have been added since he made his copy of that master branch. He has to then perform a merge, which might be an automatic merge. There might be some conflicts that he has to clean up, but he will fetch and merge. He'll make a commit, and then he will push his changes to the central server. So typically we push when we want to move the changes from our local machine to a GitHub repository. And we use a GitHub pull request to ask others to issue a pull so that our changes can be merged into theirs. This is usually done to get code into the master branch on the main repository on GitHub. And this allows us to stay current and also keep our work separate until it's ready to be pushed back into the remote repository. And this is what we're going to talk about next. GitHub is the most popular Git host. It favors a graphical user interface over a command line approach to working with Git repos. There are many visualizations that make working with Git easier. We use GitHub to collaboratively work on software projects together. There are additional tools that help teams work together, like an issues list, used to record bugs and to lay out a plan for what the team is going to work on next. There are code review and documentation tools as well. Many open source projects are hosted there, as well as many private projects from companies. So there are options to make your project only visible to certain team members, and there are options to run the GitHub software on your company's own servers. So here's a GitHub page for an open source project that I'm the creator of. Okay, feel free to go to this URL and explore it. But it has things like you can see the code, you can see some documentation about the project, you can see issues and pull requests, among other things. A fork is a copy of a repo on GitHub. In other words, it's a copy that's made on GitHub servers, not your computer. So you can fork any public repository, and the repositories have owners that usually get to choose what changes get committed to them. When you fork a project, though, you're the owner of that copied project. You don't need the original owner's permission to change anything. Okay, so here's a picture. Let's say we have the repository that's owned by Alice, and Bob wants to make a change. So what he can do is he can fork a copy of Alice's repository. Now, this copy is not on Bob's machine yet. It's still on GitHub servers, but Bob now owns and is in control of the copy. Cloning is how you copy a repository on GitHub to your local machine. And all you need is the URL of the project, and you get access to the repository with all of its branches. So you can alter your cloned copy, and it will have no effect on the source of the clone on GitHub. If the source of the clone on GitHub came from a fork, your changes will have no effect on it either. So in this case, Bob clones his forked copy of the repository. That means he can make changes on his machine, but they won't have any effect on the two repositories on GitHub servers. A push is how you send the changes from your local repository on your machine to the source of the clone on GitHub. Okay, so in this case, after Bob has completed some work, he can push the changes, and the changes will then be in the copy of the repo on GitHub servers. That's what the little star next to that name means. Now, a pull request is an appeal for another repository owner to pull in the changes from your GitHub repository. If the other repository owner agrees that the new code is an improvement, what they will do is they'll fetch and then merge those changes into the original repository with a pull. Now, additions to the master branch of a repository should always come through a pull request. You shouldn't let developers push directly to the master branch. So relying on pull requests is a good way for the team and its administrators to choose what gets added to the master branch. If all of the developers have write privileges, then there's technically nothing stopping any of them from adding code to the master branch directly, but it usually makes sense to have someone like a manager or a lead developer verify that someone else's changes really should be added to the master branch. So if all the additions go through a pull request, then one or more people can decide what goes into the master branch, and they can decide what gets left out. So here in the final step here, Bob might issue a pull request to Alice. Alice would look at Bob's changes, perhaps download them and test them. And if she likes them, what she would do is she would accept the pull request, which would do an automatic fetch and merge of Bob's changes into the original repository. So what I'm going to do next is I'm going to alter the names again. This time though I'm going to use GitHub. So the first step is to create a repository like I did before. So I'm going to go up here, create a new repository. I'm going to call this branch repo GitHub. Okay, and we'll see that this is our new current repository. Now I'm going to open the text editor and add the names and commit several times. Okay, next I'm going to look at the history here, and we'll see kind of the code evolve, or the text file evolve with all the different names. Okay, so far I haven't done anything in particular with GitHub. The next step is to publish this repository on GitHub. So you might notice there's a button right here that does exactly that. Okay, and it's going to ask me for some information. So first of all, the name of the repository. I can put a description here. You need to deselect this because GitHub charges for private repositories. I want to make this one public and free, so I have to deselect that. And now I'm going to hit the publish repository. Now, of course, when I installed GitHub Desktop, I had to enter in all my GitHub credentials. That's how this is going to work so seamlessly. So I'll publish the repository. Okay, and if I go to github.com and actually look at my profile, we should see this new repository. Okay, and here it is. I'm going to click on it. Okay, and you can see some things. Looks like there are 5 commits. So for the 4 names plus the initial commit. There's just the one branch, the master branch. And then on GitHub we can actually look at the code as well. So I'm going to click on names.txt and we can see the current state of that code. Okay, next what I want to do is I want to create a branch. So I'm going to create my professional title branch again and make my 2 commits. So we'll go up here, branch, new branch, professional title. Okay, so now that I'm satisfied with this professional title branch, I think what I want to do is I want to publish this branch. I want to send the changes back to GitHub. And if I refresh the project page, we can see now there's 2 branches. There's the master branch and the professional title branch. Now you can switch your branches from the web app here. Notice there's a button here that says right now we're on the master branch. If I want to move to the professional title branch, I can do that. And now we'll see there are 7 commits. So the professional title and the bug fix. If I go back to the master branch, there'll only be 5 commits. Okay, so many of the things you can do either on the command line or in GitHub Desktop, you can do from the web interface of GitHub also. Okay, so what I want to show is, well, what if there really were 2 developers working on these 2 features at the same time, the professional title and the middle names? Rather than using GitHub Desktop to do the middle name branch, I'm going to actually do it entirely in the web browser. Okay, so you can do a lot of things in the web interface with GitHub, including editing code. Now, I actually wouldn't recommend you do this too often, because of course if you're editing code in the web browser here, you can't really test the changes. Okay, you can't compile your code and run it from the web browser, but you can edit it. So I'm going to go back to this page and make sure I'm on the master branch, which I am. And I'm going to create a new branch. I'm going to create the middle names branch. Okay. And you'll see, again, this is something we could do right from the web app. We can create a new branch from master. Okay. And what I'm trying to do here is kind of simulate the second developer working on their own machine. Okay, so if we click on names.txt, you'll see there's an option over here to edit the file. So I'm going to go and add all the middle names. And this is a fairly basic editor, not a great editor. And then down at the bottom of the page, there's an option to commit. Okay, again, if I look at the commits, we have the middle names have been added. Okay, so let me change all the middle names to middle initials. Okay, then I'll look at all the commits on this middle names branch. Okay, and because I feel confident that these changes are an improvement to the code, what I can now do is issue a pull request to get these changes to be put back in the master. So let me make sure I'm on the middle names branch, and I'll do a new pull request. Okay, here I can, it's got a title and comment. So here I can describe, what are the changes. Okay. This little message is going to go to the owner of the repository, or the person in control of the master branch, and they're going to get the opportunity to either pull the changes in or ignore them. So I'm going to create the pull request, and then we have the option here to merge the pull request. So there are no conflicts. GitHub has checked to make sure that's the case. And I'm just going to accept the pull request because I think these are good changes. I'm going to confirm, and it's going to perform the merge. I can go back to the project. Notice here I'm on the master branch, and there are now 8 commits. So the 7 commits plus the merge. Okay, so that whole exercise was to kind of pretend that there was this other developer working at exactly the same time as the developer working on the professional titles. So let's go back to the developer working on the professional titles. They have several changes that have to do with the title. Okay, and what I need to do now is, instead of just pushing my changes, okay, what I want to do is I want to go and fetch the latest changes from the master branch. So if you go to the branch menu and say update from the default branch, that's going to pull any changes from the master into my repository. And it's going to tell me, well, there were some conflicts found on that one line. and that my working copy has been updated, and I need to clean that up. So I'll go to my editor and clean up the code. Now that was a change. Me cleaning up that code was a change, so I have to commit that. Okay, and what I want to do is I want to push those changes to the professional title branch on GitHub. So let's go back to GitHub. We will switch to the professional title branch. So we'll see all those changes with the middle name changes that I pulled in, plus my professional title commits that I have. So all of these are now currently on the professional title branch. What I want to do next is issue a pull request to get them in the master branch. So let me make sure I'm in professional title, and I'll issue a new pull request. Create the pull request, and then I'm kind of cheating here. I'm the only developer associated with this, but let's say I was the lead developer, and I get to be the one that decides whether to accept the pull request or not. I'm going to say yes, let's merge it in. I'll confirm that. Go back to the repository, make sure we're on the master branch, look at the commits, and now we have all the commits from both branches merged into the master. And if we look at names.txt, we have the middle initials and the professional title. So basically you can fork an open source project. Again, you would only do this if you're not a trusted member of the team. Then you would clone the repository onto your machine. You would create a new branch for the development on that local machine. You'd write some code and commit it regularly. And then when you're ready to add your code to the master branch, you would push the changes to the repo on GitHub. Next, you would pull in any new changes from the master branch into your local copy and merge them, and resolve any conflicts if there are any, and then push the merged version back to GitHub on your branch of development. Finally, you would create a pull request to have someone on the team accept those changes, and then basically you start all over again at step 3. So you create a new branch for the next thing you're working on and repeat. Okay, so that's the basics of using GitHub, and we'll do more in class.